Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started a discussion with trigonometric ratios up to transformations. Then we have discussed trigonometric equations in our previous sessions. Today we are going to start a new chapter, that is inverse trigonometric functions. What is this inverse trigonometric function? Right? First of all, what do you mean by the term inverse? Have you heard about inverse anywhere? Right? We used to hear about additive inverse and multiplicative inverse, right? What do you mean by additive inverse? Additive inverse is just negating or applying minus sign to it, right? Or else if it is a multiplicative inverse, that is nothing but the reciprocal, right? Usually the inverse, the term inverse represents a multiplicative inverse, right? Then why do we have inverse trigonometric functions, right? If I want to inverse it, or if I want to do the reciprocal of a particular trigonometric function, we have one more trigonometric function. Yes or no? For example, if there is a sine function, sine trigonometric function, what is the reciprocal of sine? That is nothing but cosecant, isn't it? Yes or no? Fine. That's what we used to study in our previous chapters. But what is the need of this inverse trigonometric function? Yes or no? Fine. In order to know the actual reason, we should discuss the chapter, that is functions. What is a function and why do the inverse exist of a function? Okay, that is the main reason for finding inverse trigonometric function. Is it clear? We'll discuss more about what is an inverse and everything in the chapter functions. As of now, we will discuss how to simplify a sine inverse, cos inverse kind of questions, right? How to convert them into normal trigonometric functions and how to convert a normal functions into inverse function, right? How to solve that particular equations. Okay, is it clear? Shall we start? Now see here, the basic inverse trigonometric functions are, however, we will have 6, that is sine inverse, cos inverse, tan inverse, cot inverse, secant inverse and cosecant inverse, right? In the previous chapter we discussed about the domain and range of a trigonometric function. Here we will discuss the range and the domain of a inverse trigonometric function. Is it clear? If you remember, if there is a function f of x that is equal to sine x, right? What is the domain? Domain in the sense we have to substitute the values in it. What is the range of values that we can substitute in the x? That is nothing but our minus pi by 2 to plus pi by 2. Then what are the values we are going to get? That is minus 1 to 1. This is domain, this is range. Is it right? Here this will be reversed. That is, this will be the range. This will be the domain of sine inverse x and this will be the range of sine inverse x. Is it clear? If you observe here, sine inverse of something, whatever the value it might be, that is, we have taken sine. Here sine get cancelled, we will get theta, where theta belongs to minus pi by 2 to plus pi by 2 for a sine function. Even that will be 0 comma pi for cos theta, isn't it? We can get minus 1 for this also. Yes or no? Fine. Similarly, tan inverse of tan theta is minus pi by 2 to plus pi by 2. Cot inverse cot theta is 0 to pi. Did you understand? These are the different kinds of ranges of sine inverse sine theta, right? Don't get confused. Here sine inverse of sine theta, sine inverse, if it is outside, then this is nothing but your inverse trigonometric function. Therefore you will get the answers as angles. Yes or no? And here sine of sine inverse x, whatever might be inside, here it is sine. Sine of something will be some real value, right? For example, sine pi by 2, that is 1, or else if it is sine pi by 4, that will be 1 by root 2, where it lies between minus 1 to 1. Is it clear? Did you understand? Fine. Here also cos of cos inverse x, its range lies between minus 1 to 1. Yes or no? Similarly, for tan x belongs to R, for cot also x belongs to R, for secant again we know this kind of things, right? Except minus 1 to 1, it lies in all other states. Even for cos inverse, cosecant inverse x also the same thing it defines. Clear? For secant also 0 to pi by 2 to pi. pi by minus pi by 2 to 0, 0 to pi by 2. It clearly tells that here secant inverse of secant 0 or secant inverse of secant pi by 2. Right? What is secant pi by 2? 0, right? Yes or no? Because cos pi by 2 is 0, secant pi by 2 is infinity. Therefore, secant inverse of infinity doesn't have any value. That's why here except for pi by 2, this is valid for all the values of theta. Right? Similarly, for cosecant theta also, if it is sin 0 is 0. Therefore, cosecant 0 is infinity, which is undefined. Therefore, this is valid for all values of angles except at 0. Is it right? Did you understand? Fine. There is a basic broad overview of inverse trigonometric function. Right? What is that? You have to remember sin inverse of sin x is x, or else sin inverse of sin theta is theta, or else sin of sin inverse x is x. But you have to remember the main thing is sin inverse of something, whatever it might be, that is always an angle. Sin of something, that will be a real value. Is it clear? Did you understand? That is the thing, and let us discuss one more thing. That is, see here, we used to have different identities in our trigonometric functions. That is, sin square plus cos square is 1, secant square minus tan square is 1, and cosecant square minus cot square is 1. Similarly, we will have same thing in our inverse trigonometric functions also. That is, cos inverse x plus sin inverse x is equal to pi by 2, tan inverse x plus cot inverse x equal to pi by 2, secant inverse x plus cosecant inverse x is equal to pi by 2. You have to remember these kind of identities for our chapters. Okay. Even if you don't remember the range for IP kind of questions also, it's okay, but it is mandatory for your competitive exams. As of now, at least try to remember how to solve these things and just try to remember these three identities. Is it clear? Did you understand? Once again, let me tell. The inverse trigonometric functions are the trigonometric functions where its inverse exists. Right? What do you mean by the inverse exists? Right? We'll discuss everything in the chapter function. What is a function? Why it is called as a inverse function? When do inverse exist? Right? What are the conditions to be satisfied? Right? And what is domain and range? Everything. Is it clear? Fine. Let us do few problems and examples of this kind of chapter. Let's start. Now see here, what are the questions given here? That is, he is asking us to find the values of sin inverse minus 1 by 2. Do we get 1 by 2 in sin? Yes, we get, right? That is, we can write it as sin inverse of, when do we get minus 1 by 2 in sin? Right? Remember, it should lie between minus pi by 2 to plus pi by 2. Is it okay? 1 by 2 is sin 30, that is pi by 6. Can I write it as sin minus pi by 6? Isn't it? Yes or no? Now tell me, what is the answer here? That is nothing but minus pi by 6. However, it belongs to minus pi by 2 to plus pi by 2. Is it clear? Did you understand? Once again, let me tell here. Sine of minus half. Do we get half in sine? That is in the pi by 6. Then there is minus. Then what to do? Sine of minus theta is minus theta. Therefore, this can be written as minus sine 30 or nothing but sine of minus 30. Right? Even one more thing you can remember is sine and sine inverse get cancelled. You can remember like that also. Therefore, you will get minus pi by 6. You have to check whether it lies between minus pi by 2 to plus pi by 2. Yes, it's lying. Therefore, this is our solution. That's it. Did you understand? Now, check the second one. Tan inverse 1 by root 3. When do we get 1 by root 3? When that is 30. Tan 30 is 1 by root 3. Therefore, it can be written as tan inverse tan pi by 6. Therefore, the answer is pi by 6. Does it lies between 0 to pi? Yes or no? This should lie between 0 to pi. Therefore, we don't have any problem. Therefore, this will be my solution. Right? The next, cot inverse minus 1. Do we get minus 1 in cot? When it should be minus 45. Right? Write it as cot inverse minus 1. When do we get minus 1? Either it can be, because cot range is 0 to pi, either it can be minus cot pi by 4. Right? Is there any minus cot pi by 4? Can I write like that? No, because the range starts from 0 itself, right? Therefore, we can write it as cot pi minus pi by 4. Is it right? 180 is pi minus pi by 4. Therefore, it lies between 0 to pi, and in the second quadrant it is negative. What is cot of 180 minus theta? That is minus cot pi by 4. Is it clear? Instead of that, let us write it as cot pi minus pi by 4 is 3 pi by 4. Is it clear? Now tell me, after cutting both cots, I will get it as 3 pi by 4, which belongs to 0 to pi. Is it clear? Yes or no? Now the last sum, that is secant inverse root 2. When do we get root 2 positive for secant? When that is in 45. Secant inverse secant pi by 4, that is equal to pi by 4. Yes or no? What is the range of secant? Tell me. It however belongs to pi by 2 to pi. It however lies between 0 to pi by 2, pi by 2 to pi. Is it clear? Did you understand? Shall we do few more problems? Let's do. The next question given here it is, he is asking us to find the value of sine inverse sine of 4 pi by 3. How do we find? Right? You can find in different ways. The one way is to find is, what is 4 pi by 3? What's the value of it? Do you know the value of sine inverse sine of 4 pi by 3? Right? What is pi by 3? 60. 60 into 4 is 240. What is the value of sine 240? That is nothing but 180 plus 60, right? Let us write that, which is sine inverse sine of 4 pi by 3 can be written as pi plus pi by 3. What is sine pi plus pi by 3? That is in the third quadrant. That is nothing but minus pi sine pi by 3. Yes or no? Right? Minus sine pi by 3. That is nothing but sine of minus pi by 3. If I cancel these both, my answer will be minus pi by 3, which always belongs to minus pi by 2 to plus pi by 2. Did you understand? Now let us do the same thing for 4 pi by 3 of tan. Okay. Now see here, tan inverse of tan 4 pi by 3. Check whether 4 pi by 3 lie in the limits of tan. What's the range of tan? 0 to pi, right? That is 0 to 180. 4 pi by 3 is somewhere 240. Right? Now we have to get into our limits. What is that we have to do? Again, we will write 4 pi by 3 as pi plus pi by 3. Is it okay? What is tan of pi plus pi by 3? That is in the third quadrant. Obviously, tan is positive. Therefore, it becomes tan pi by 3. Here if tan and tan get cancelled, I will get it as pi by 3. Always that belongs to 0 comma pi. Is it okay? Did you understand? And the next question. There is some kind of odd one out of all these questions. See here. Here sine of cos inverse 5 by 3. What is that we need? We always need that it should be, both should be either sine, both should be either cos. Then how to do? What to do? Let us solve this in different ways. How to do it? Now see here. Inside there is cos inverse 5 by 3. Yes or no? Now let us take cos inverse 5 by 3 as x. Okay. Now see here. What it will become? Let us assume this to be equal to x. Then cos x is equal to 5 by 13. Is it right? Can I find out sin x here? Yes or no? If cos x is 5 by 13, let us draw the diagram. I am erasing this. See here. See here. If this is x, adjacent is 5, hypotenuse is 13. Then what about the opposite side? I know that opposite square plus adjacent square is equal to hypotenuse square. Here it is adjacent by hypotenuse. What is adjacent? 5 square. Hypotenuse is 13 square. I have to find my opposite square. right? What is the opposite now? 169 minus 25, that is 144. Therefore, opposite is 12. Yes, this is 12. Clear? Then, what is that we have to find? That is sin x we have to find. What is sin x now? Opposite by hypotenuse. Sin x is opposite by hypotenuse. Therefore, sin x is 12 by 13. From this, x is equal to sin inverse 12 by 13. Isn't it? We can write like that, right? Let us substitute that here, right? Therefore, x is nothing but cos inverse 5 by 3. Here, x is nothing but sin inverse 12 by 13, right? Let us substitute that here. I am writing it here, just try to understand. Therefore, sin of cos inverse 5 by 13 is equal to sin x. This is x, right? We can write directly it as 12 by 13, or else you can even write one more step. Sin of, what is this? Sin inverse 12 by 13. If we cancel these both, I will get it as 12 by 13. It belongs to minus 1 to 1. Yes or no? Sin of cos inverse. Here it is tan inverse. If it is outside tan inverse, then it should lie between angles. Here it is sin of something. Therefore, it should lie in the ratio. It should belong to some real numbers. Is it clear? Did you understand? 12 by 13, obviously the value will be less than 1 because numerator is less than denominator. Is it right? Did you understand? This is what we are going to solve in most of the problems. Okay, shall we move on to the next problem? Let's do. Now see here, the question given here it is, he is asking us to prove that sin inverse 3 by 5 plus sin inverse 8 by 17 is equal to cos inverse 36 by 85. Okay, we have one formula, that is sin inverse x plus sin inverse y. I will tell you later. Before going to direct formula, let us simplify one problem by using a normal method. Shall we do? Now see here. Here, the first thing you have to do is, we have to assume each and everything as a separate variable. Let us assume sin inverse 3 by 5 as A and sin inverse 8 by 17 as B. Okay. From this, can I write sin A as 3 by 5? Here, sin B as 8 by 17. Is it right? Then, if I assume this question as number 1, then what do we get? A plus B is equal to cos inverse 36 by 85. Okay? Is it okay? Let it be like that. Now let us simplify this. What is A plus B is equal to cos of 36 plus 85? Whatever it is, this value should be this thing. Okay? Now let us write, what is it? A plus B, or else let's do one thing. Let us apply A plus, cos on both sides. What it will become? LHS is cos of A plus B, that is equal to cos A cos B minus sin A sin B. Is it right? What is cos A? From sin A we will calculate. Cos B from here we will calculate. Sin A is given, sin B is given. Okay, shall we find out that? Now see here. From this, one sin A ka triangle we will draw first. If it is A, sin A, that is opposite is 3, hypotenuse is pi. What about the adjacent value? 5 square minus 3 square. 25 minus 3, that is 16, which is 4. Right? Let us write for sin B. If it is angle B, opposite is 8, hypotenuse is 17. 17 square is 289. 8 square is 64. 289 minus 64 is 225, which is square root of 225 is 15. Is it okay? Now tell me, from this sin A, what is the value of cos A adjacent by hypotenuse 4 by 5? From this sin B, what is the value of cos B? Cos B will be adjacent by hypotenuse. Let us substitute everything in the value in this. What is cos A? 4 by 5 into what is cos B? 15 by 17 minus what is sin A? 3 by 5. What is sin B? Sin B is 8 by 70. Now tell me, 15 4s are 60. divided by 17 5s are 35, 85 minus 8 3s are 24, 17 5s are 85. Now tell me, LCM is 85, numerator is 60 minus 24. How much is it? 60 minus 24 is 36 divided by 85. Is it right? What is the value of this? This is the value of cos of A plus B. Then what is A plus B? A plus B is cos inverse 36 by 85. What is A plus B? A plus B is nothing but our question. This is A and this is B. That is sin inverse 3 by 5 plus sin inverse 8 by 17 is equal to cos inverse 36 by 85. Is it clear? Fine. What are the things you have to remember is how whatever the angles they give, we have to assume it to be A and B. Okay, or else X and Y, which is comfortable for you, that is okay. And not only that, if you observe here, we have used cos of A plus B. Why only cos? Because in the answer, he asked us to prove it as cos inverse 36 by 85. Is it clear? That's why we have used cos of A plus B. Is it clear? Fine. Now, let us remember one or two formulas. That is, sin inverse x plus sin inverse y is equal to sin inverse x into under root 1 minus y square, y into under root 1 minus x square. Right? How to remember this? We know that sin of A plus B is always sin A cos B plus cos A sin B. If you observe here, sin A cos plus cos sin. If I assume this as A and this as B, then here this term will be sin term and second term will be cos term. Right? Cos is nothing but 1 minus sin square, right? That's why we will get like this. We can even find out in this way, or else we can directly substitute in the value. Similarly, cos inverse plus cos inverse y is cos inverse xy minus under root of 1 minus x square 1 minus y square. Right? Here wherever you have x, that will be sin, or else cos A cos B minus sin A sin B. You can even remember like that. Similarly, here tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. Is it clear? Did you understand? Fine. By the next session, we expect you to remember these formula and just go through all these kind of problems which we have solved for today. Is it clear? This is for today. Let us meet in the next class with more problems of inverse trigonometric functions. Thank you.